All right, long and synthetic division. No matter what we do, now we've got the handout that was here that's got all the steps with this one. And whether we're doing long or we're doing synthetic division, the same two things at the top here are still going to be the case. The terms have to be in descending order, standard form. And then if there's any variable powers that are not present, you've got to go back and rewrite those with a coefficient of 0. So whether we're doing synthetic division or long division, those two things have to be the same for what we're doing. And we'll come back to synthetic division in a minute, but we're going to do long division first and show you. And again, long division is what it sounds like. It's long. It takes a little bit, and it's going to be well, it's going to be long. So okay, so long division. Here's the thing about long division. It keys on the first terms. So let's say we're going to take x plus 3 and we're going to divide it into x to the third plus 5x squared plus 6x minus 10. Okay, I think I shared, the story y'all the other day of me being in calculus 3, and somebody asked me, well, how do you do long division? I was just, had that deer in the headlights look of just, you just do it, and trying to figure out what it was. But the key thing is when you're doing long division, you're always going to key on the first terms. Just like if you were dividing, 7 into 963, you take the first number here, you divide it into the first number here, figure out how many times it would go, and then you're off to the races from there. This one's kind of the same thing. That when we're going through this one, you're going to divide x into x to the third. So basically, we're doing this. We're doing x to the third divided by x. Okay, and we talked about a little bit the other day that when we're doing division, that if you're going to do that one, you're basically going to subtract your exponents. So this is really x to the third over x to the first. So that's just x squared. So x squared would go there. All right, and if you were doing long division like we're doing over here, after you figure out how many times this thing will go into here, you're going to multiply these two numbers and you're going to put the number here, correct? You're going to do the same thing on this one, but just remember that when you do x to the second power and you multiply, it's really this whole thing. So it's x squared times x, which would be x to the third. And then x squared times 3 would be 3x squared. All right, now here's a question I always love to ask. Where does this minus sign come from when you're doing long division over here? Yeah, it's just what you do, right? So we talk about it sometimes, and I'm like, well, what do you mean? Where's it come from? I'm like, well, we did x squared times this, and we got this. We've got x times 3 is this. The rule is after you get these two numbers, you got to go back and subtract, and that's just what you do, right? There's not really that it pops up anywhere. So after you multiply these numbers, you've got to go back and change every single one of these signs. So we're going to change that to a negative. We're also going to change that to a negative. So then you've got x to the third minus x to the third. That's a 0, which is what we want. We want that term to be gone. Now we've got 5x squared minus 3x squared. That would be 2x squared. Okay, and then we start the process over again. Now we've got this term first, and we've got this x. So now we're going to take 2x squared, and we're going to divide it by x. Okay, so if we do that, we're going to cancel off one of the x's. So that'll leave us with, and I can really get rid of that one, that'll leave us with a positive 2x. Oh, what do we have to remember to do? You got to bring down the next term, right? So we've got to remember to kind of do that same thing over here. We did 9 minus 7 to get 2. Got to bring down the next number. Same thing with this one. You got to bring down the next number. So now when we multiply by 2x, it's 2x times x for 2x squared. And then 2x times 3 for 6x. And I would almost, if it's positive, not even put the sign. because if we're doing long division, we've got to go back and change this from a positive to a negative. Same thing. This was a positive. We're going to change it to a negative. Okay. And again, we want to do that because the first term now goes to 0, which is what we want. This thing is gone. We've got 6x minus 6x, which is 0. So that term also canceled out. And then we're going to bring down the next number, right? So we got a minus 10. Okay, so if we've got 0 minus 10, can we divide x? If we do negative 10 over x, do we get anything from that? Nothing to cancel, right? So there's really nothing else going on at that point. So once we're there, we've done the division, we get to here, there's nothing else that will cancel. So if you go, for this one, we're just kind of done. So then this negative 10 winds up being your remainder. And the way they're going to draw these problems out, the way they're going to set the answer is you're going to take whatever you've got up here, so it'll be x squared plus 2x, and then instead of just putting a remainder negative 10, they're going to do this is a minus, and then we're going to do 10 divided by this thing here of x plus 3. And that's going to be your answer. Okay, a lot of stuff going on, right? Because it's a lot more complicated than the old just division with numbers, because now you've got, when you divide these two numbers, you've got to remember to do distributive property. So it's x squared times this and x squared times this, and put those in. Then you got to change the signs, and then you get to subtract, and you got to go back and pull back down, and you start the whole process back over. So long division is, it's what it sounds like. It's a long process. And again, we only did x to the third. If we start with x to the fourth or x to the fifth, we basically kind of almost doubled the amount of work that we have to do. Okay. So here's what we're going to do. So for synthetic division, it's a shortcut. And it's a shortcut when what you're dividing by, which is the divisor. If you go back to like the old, terms of what you have there. So synthetic division is a shortcut when the divisor, what you're dividing by. So your divisor, that's what's on the outside. In that case, that was the x plus 3. You can use it when you have x either plus or minus some constant that you've got here. So basically that your x term has a coefficient of 1. If you've got x plus 3 or x minus 5 or anything like that, it's fine. It's just the main thing is that your x has a coefficient of 1. Okay, that's kind of the big thing. You have to have x plus or x minus something, that your x coefficient has to be 1. If it's 2x plus 3, like we're up here, we're doing division with x plus 3, we actually could have done synthetic division, and we'll actually do that next. But that one, we could have actually done synthetic division. If this had been 2x plus 3, when we're dividing up here, you would have to do long division. So if this was 2x plus 3 or 3x minus 2 or 4x minus 1 or whatever it is that you were going to do, you would have to do long division. But if it's just x plus, we actually could do synthetic division with this problem. Okay, so what we're going to do is we'll actually take this problem we've got here and show you how quick it would go if we were doing synthetic division. Now, first time we do it, it's going to take a little while because we're going to take our time, go through all the steps, and kind of ease into it. But once you get used to it, it actually goes really, 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 really quick when it comes off of it. All right, so here's our steps. First thing, again, we said we've got to make sure the terms are in descending order, which they are. All the powers of x are present. They are, and we'll show you one in a minute where this is not the case. And then what we're going to do, instead of doing like a normal division, we're going to draw the division bar upside down. Okay, so if you want to keep those notes there, we're going to take this same problem we've got here, and we're going to do synthetic division. So we're going to do x plus 3. And we're going to divide it into x to the third plus 5x squared plus 6x minus 10. Okay, exact same problem, but this time we're going to do synthetic division instead of doing long division. Okay, so what we're going to, now, this is usually going to be your number. So we're going to draw the bar upside down and leave one extra row of numbers because we're actually going to do the work. All the work is going to be right here when we do this thing. Okay, so we're drawing the division bar upside down. We're going to bring down just the coefficients on the inside. We're going to bring down the 1. And go ahead and bring down the signs too. Bring down the plus 5, the plus 6, and then the minus 10. Okay. On the outside, we're going to bring down only the constant that we've got here, only this plus 3. But when we bring it down, instead of making a plus 3, we're going to change it to a minus 3. Okay, and I know somebody's thinking, why are we going to change the sign? All right, so here's what we're going to do. Here's why you change this sign here. Because, you know, when we introduced all the negative signs back here, and we did all the changing of signs of stuff, that instead of doing that, where we're going to change these signs all the time, we're going to introduce the negative sign here, and we don't have to change any other signs after that. That this is going to take the place of changing all those signs that we did here in the long division. So we change it once here, we don't have to worry about changing it again. So then after that, we don't change anything. Okay, so the very first thing is you're going to take the first coefficient you have here, put it down below the division bar, and that one's going to kick everything off. And then from here, we're just going to multiply negative 3 times 1, and that answer is going to go right there. Okay. And then with these signs and numbers, you just do what it says. It's 5 minus 3. Oh, that's 2. We've got negative 3 plus 2, which is negative 6. Just multiply negative 3 times 2. We've got 6 minus 6 is 0. And then we're going to multiply negative 3 times 0, which is 0. We'll put that number here, and we'll do negative 10 plus 0 minus 0. Doesn't matter what it is because it's just 0. So it leaves with a minus 10. Okay, and there's your work. So that's a lot, to me, that is a whole lot faster than all this stuff we did here with the long division. Okay, and you may be saying, well, all we got is numbers. We don't have any x's. Okay, so if we're doing this, now here's where we kind of borrow from the first part. If we key off what we're doing in long division, it was x to the third divided by x. So the very first term, we're going to bring it down in power. We're going to subtract these, and it's going to start off with x squared. So this one, we know that this number is always going to do the same thing. It's still going to borrow that one. So this first number is basically going to be 1 x squared. And then the next term, if it's in descending order, now we're going to take this one down in power of x because we would take this thing and divide by x. This is going to be a 2x. This would be your constant term, which was 0. And then whatever that last number is, again, that's always your remainder. So that's our leftover. So instead of just doing remainder negative 10, we're going to put minus and then 10 over whatever it was we were dividing by, which was the x plus 3. Okay.
No, plus 0.
Yeah. Okay. And because of that being a 0, adding 0 doesn't do anything. Because normally this would just be a constant, 0 or 8 or 10 or 6 or something like that. But it's plus 0, so we really don't need it. We don't also need the 1x squared. So we can just say that this is x squared plus 2x and then minus the 10 over x plus 3. that as long as these terms are in descending order here, then these answers will also be the same way they'll be in descending order. So this is going to be x to the second, x to the first, basically x to the 0, and then your remainder power there. Oh, just kind of like we would do, like if we're doing the long division back up here, how you always kind of would key on like the first terms that you would always knock everything down a power because if we're dividing it by x. This one's going to be basically the same thing. That it's going to, and that's kind of the neat thing about doing synthetic division is you don't have to worry about any powers other than just knowing that the first power is going to be knocked down a power of 1, and then everything after that will also be 1 less power after that. So it's just a shortcut to kind of speed the whole process up. Okay. All right, let's do another one of those just to make sure we got it. No, and that's what we were saying, that if we clean this thing up, the plus 0 doesn't do anything. So if we'll clean this thing up, and again, we don't need the 1 with the x squared. We can just make it x squared plus 2x, and then minus the 10 over x plus 3. All right, so that was our first example. That was example 1. Let's get another one here. Let's make sure we're okay. All right, let's change it up a little bit. Let's do x minus 2 this time. Let's divide it into x to the third plus 2x squared minus 5x plus 3. Oh, y'all can't see it, can you? There we go. Okay, so same thing. Just flip the division bar upside down and leave extra room because this is where you're going to show your work. It's 1x to the third. It's a plus 2. It's a minus 5. And a plus 3. Okay, and with the x minus 2, again, the one thing you want to do is change this minus sign to a plus. So it's a positive 2. Okay, and the first number is always a default answer. Whatever that number is, we're going to put that same number there, and that kicks everything off. So now it's 2 times 1, which is 2. And then just do what it says. 2 plus 2 is 4. That's a positive 4. All right, and we've got 2 times 4, which is 8. Negative 5 plus 8, or 8 minus 5, positive 3. And then we've got 2 times 3, which is 6. And then 6 plus 3 is 9. Okay. And again, once you kind of see that that's synthetic division, the work is a million times easier than doing long division. You don't have to worry about distributive property or changing any signs or anything like that. It's just bring down the first number, multiply, add, subtract, multiply, add, subtract, multiply, add, subtract. And just the work is easier. Now, again, as long as all the terms are in descending order, the answer is going to be the same way, but because we're dividing x to the third by x, we're going to knock it down 1 power. And that will be the case every time in synthetic division. So instead of with x to the third, this one's going to start with x squared, 4x plus 3. Okay, and then the last piece of it here, we got the 9, so we'll do a plus 9. Again, that one, the last number is always your remainder, and you're going to put that over whatever you're divided by. So that'll be over x minus 2. Okay, so let's do this. Let's do one where there's some missing terms so that you can see what's going to happen if you've got a term that's missing. All right, so for this one, let's do x plus 2. Let's divide it into x to the third. Let's just make it really, let's say it's just x to the third plus 4. Almost a perfect cube like we were doing yesterday with the factoring, but not quite. This one's just x to the third plus 4. If it had been x to the third plus 8, we could have done something with it, but we'll just leave it x to the third plus 4. All right, so here's the thing. It's in standard form because we've got x to the third and we've got 4. But when we're saying that there's terms missing, there is no x squared term, correct? So if that's the case, we need a 0x squared term. You would also need a 0 for the x term. So you've got to have all the powers there in descending order. So when we started with x to the third, you've got to have a x squared term, you've got to have an x to the first term, and then you've got the plus 4, which would be your constant term. So if they give you something like this, and if there's any powers of x that's missing, you have to go back and write that term with a 0 coefficient so that you'll know that everything lines up so that you actually can do synthetic division for that part. Okay, so that's really what this thing becomes, and now we're going to take and flip it upside down with the coefficients. Okay, so we've got 1x to the third. We're going to do I guess we do a plus 0. We don't necessarily have to put a plus, but it just to kind of make sure we've got a sign that's there. We've got a plus 0, and then we've got plus 4. All right, and on the outside, just make sure you change that from a positive 2 to a negative 2. And then we're ready to go for the division part. All right, so again, first term, bring it down. So it's negative 2 times 1, which is negative 2. 0 minus 2, that's just going, 0 doesn't do anything, that's just going to make it negative 2. So now we've got negative 2 times negative 2, which is positive 4. Again, the 0 doesn't do anything. And then negative 2 times 4 is negative 8. 4 minus 8 is negative 4. Okay, so we're going to, instead of starting again with x to the third, we're going to start with 1, which is just x squared. This is going to be your x term. The plus 4 is your constant, and this minus 4 is your remainder, so it's going to be minus, and then 4 over, and we were dividing by x plus 2. Okay, and that's about the only trick question they can throw at you. Now, besides the terms not being in descending order, if it's not in standard form. So if it's not in standard form, if they had 4 plus x to the third, you'd have to go back and write it in descending order. But once you've got it in descending order, other than skipping a few powers, there's really not anything they can do trick question-wise to go through these. Okay, and then the only last couple of things that we have, and this is more like just a couple of details to make sure that you got it. When you're going through this one, I think this is also on the sheet that's here. But at the end, it says one extra note. If the remainder is 0, then what you divided by is a factor of the expression. And if what you divided by is a factor, you set that factor equal to 0 to find a solution. So basically, if you've got that, if the remainder is 0, it's a factor. And if it's a factor, then you can set it equal to 0, which can then make it a solution. So one of the things they talk about, and that's basically just the remainder theorem, or the factor theorem that they talk about, basically says if your remainder is 0, then what you divide it by is a factor, which could also be a solution of it. The only other thing that they have that they throw at you is this. It's the remainder theorem. And the remainder theorem basically just says this, that the remainder theorem, it's a check for synthetic division. Now, it's not the greatest check in the world, but it's a check. Okay, and how that you get to check it is basically this. You evaluate, and remember, evaluate is just another fancy way of saying plug in. You get to evaluate the expression using the number used in synthetic division. So for this problem back up here, we were using -2 in our synthetic division. So if we were going to evaluate this thing, we would do the same evaluation, but we'd use -2 for the number. So again, it's just a check for synthetic division. You're going to evaluate the expression using the number that we're using in synthetic division. And the way that you check this thing is the answer you get when you evaluate it has to equal the remainder from synthetic division. Okay. So sometimes they may just ask you, is this thing a factor or not? Which basically means you can do synthetic division and see if the remainder is 0. Or if they say, all right, is it just a factor and you're not worried about anything else that's going with it, you can just take this -2 that you have, plug it back into the expression, and then see what it is, and see what's going to happen there. So if we go back to this example up here, so if we go back to this previous example that we had, again, this one's kind of short, so it works out pretty easy. We're going to take -2, and we're going to plug -2 back into x to the third plus 4. So basically, that's our x value. Or a lot of times they'll do this thing. They'll do like, since it's a polynomial expression, they may do like p of -2, and they may say, or they may do r of -2s because they want to use the remainder theorem, and they may just say, all right, here's some number we want you to plug in and evaluate it and see what you get. It could be an r, it could be a p, it could be any variable for the expression you got. But basically, you're just taking this -2 and you're going to plug it back in. So that would be -2 to the third plus 4, which would be -8 plus 4, which would be -4, which is the same thing that we had for our remainder right there. Okay. And again, that one was really short, which is actually okay. But the remainder theorem just basically says that. Just take the number you were going to use in synthetic division, plug it back into the original expression, and then the remainder should be the answer, or the answer you get here should be the same thing you get for your remainder. Question? Are you straight?
So, with the 0 thing, like at the very, do you think you can do a problem like that?
Yeah. Yeah, we can do one with a 0 remainder. Let's see, I should have one here. Yeah, here we go. So you want to see it like remainder theorem, or do you want to see it division, or do you want to see it both ways? Because we can do both. It won't take very long to do it. So we'll do both. Okay. All right. Do one more synthetic division one here. And then we'll check it with synthetic division, or we'll check it with remainder theorem. Just make sure we're good. All right. So let's do x plus 2 Let's divide that into x to the third plus 4x squared plus x minus 6. All right, so division of r upside down. Coefficients are 1, positive 4, positive 1, negative 6. And again, we're going to change that from a positive 2 to a negative 2. All right, again, first number doesn't change, just bring it down. So it's negative 2 times 1, which is negative 2. 4 minus 2 is a positive 2. Negative 2 times 2 is a negative 4. 1 minus 4 is negative 3. Negative 2 times negative 3 is a positive 6, which means that's a 0. And again, as soon as you get that this is 0, that means that x plus 2 is a factor. But also at the same time as this negative 2 that we get here, so x equals negative 2, would also be a solution. And that's kind of what they're trying to get you to see, that if you get to the end and this is 0, you can say it one of two ways. You can either say that this thing we were divided by is a factor, or you can say that this number is actually a solution to this thing. Okay, and then your leftover answer then is that then this is going to be x squared plus 2x minus 3. And again, since remainder is 0, we don't have to put anything. Math Excel, they may give you a box with the remainder equals, and you just go back and put a 0 there. So I think they'll probably have something like that where you put the expression, and then I think they give you a box with the remainder, and you just put that remainder number in there. I think that's the way Math Excel will go through that. Yes.
What does that mean by like x plus 2 is a factor?
Oh, so basically, it's this, is that if we were, and this is kind of where we're going to go after the next test that we've got coming up here, that basically, if this is a factor, we're saying that if we want to try to factor this, like we did factor by grouping, because factor by grouping wouldn't work on this particular problem, but if we get this thing equal to 0, that means we could factor this thing as x plus 2 times this answer that's here. So we could take this expression that we've got here and rewrite it so it looks like that. And that's where we're going. That's the next step we're going to do, but we'll do that on the next test because we've got to make sure everybody's okay with synthetic division. But that's actually where we're going to go. And then if you look at this, you could probably go, oh, the factors of negative 3 that equal positive 2, that's going to be x plus 3 and then x minus 1. So really, you could take this whole thing here and rewrite it as that. And this would be one of those cases where if you try to do synthetic or try to do factor by grouping wouldn't work with this one because the terms just don't match up the correct way. But if we do synthetic division, we can figure out that, oh, that remainder is 0, so that gets us here, and then we can factor that because that's just a regular trinomial.
I was doing like the big homework assignment, like for like 3.1, 3.4, and I think one of these problems came up, and that's why I